We are live. Hi everyone, welcome back to Code Era. Today in this video we'll be discussing the LeetCode daily challenge for today, that is 7th of December, and the challenge name is minimum cost to move chips to the same position, right? So this is the problem of the day for 6th December. So just quickly give me a +1 in the chat if I am audible to everyone and my screen is clearly visible, so that we can begin ahead with this problem. Daily challenge. Is is everyone able to hear me and my screen is also clearly visible? Just let me know in the comments. Give a +1 and then we'll begin ahead with today's session, right? So we'll be discussing this problem and it is an easy level problem, but still there is some trick behind this question, right? Just quickly give. Okay, so hi Vanshika Kapoor. So all those people who have joined this, please give me a +1 in the chat so that we can begin ahead. And immediately after that, right, I'll just wait for 1 or 2 minutes more for everyone else to join in, and then we'll begin ahead with our session. So this problem is easy level and it has approximately, I think it has a lot of submissions. Let me check. So this problem is having around 1 lakh submissions, where 74,000 submissions are accepted. This was it about this problem, and it I think it has been asked in several companies as well. Okay, right, so let us begin ahead with the problem. So the problem says that we have been given n chips. So you have been given n chips, right, where the position of the ith chip is position I. So you have been given n chips and the position of the ith chip, right? The position of the ith chip, you have been given n chips. This is important, right? Let me read it again. So you have been given n chips where position of ith chip is given in the array, that is position of I. What does this mean? Let's say if I have an array 1, 2 and 3, then I will say that position of first chip is 1. Then I will say that position of chip 2 is 2. After that I will say that position of chip number 3 is 3. You will say that okay, this is no problem, right? This seems very simple, but let me give you another example, right? So I hope that this much part must be clear, right? In this, what you have been given is, you have to just notice one thing, that you have been position of the ith chip. This is the statement, position of ith chip is given as position of I in the array, right? Position of the ith chip is given. The value of the chip, that is the number of the chip, is I, and its position is position I in the array, right? What does this mean? Let's say that I have a case where 2, 2, 2, 3 and 3. If this is the case, right? So in this case, can someone tell me? So let's index this out. 1. Let's do a 1 based indexing here, because the 0th chip will not be there, right? 1, 2, 3, 4 and 5. So in this case, what happens is that I will say that position of chip 1 is 2, right? Next I'll say that position of chip 2 is 2. I will also say this. Then I will say for the next one as well, that position of chip number 3, which is this chip, is also 2, right? After that I'll say that position of chip 4, that is just this chip, 4th chip, is 3, right? This is what I'll say. After that I'll say that position of chip number 5 is 3. Is this much part clear to everyone? Is the position part clear to everyone? Is this much part clear to everyone? That means, that simply means that at the position 2, it will look like this. It will look like this. At position 2, I'm having the chip number 1, chip number 2 and chip number 3. At position 3, I'm having the chip number 4 and chip number 5. Is this much part clear to everyone? Just quickly tell me in the comments if this much part is clear to everyone or not. Only then I'll be able to move ahead. Is this part of the question clear to everyone? In the for the ith chip, assuming a 1 based indexing or even a 0 based indexing, you can, if you are taking 0 based indexing over, even that is not a problem. So the position of the ith chip is given as position I in the array, right? Is this part clear to everyone? Is this much part clear to everyone? Just quickly let me know in the comments. Only then I'll be able to move ahead. Okay, clear, right? So this means that you will be given an array. What is this array? You have been given an array and the name of this array is position, right? So what you will be given is the value that is position I represents what? It represents position. Represents position of the ith chip, right? Of the ith chip. This will be perfect. Everyone will be clear with this. And index that is I represents the chip number. Everyone is clear with this? The first chip, chip 1, chip 2, chip 3, like this. This much part must be clear to everyone. This is very important in this question. You should be knowing about this question, right? What does it actually state? So position of I represents the position of the chip, right? So as I told you, let's say 2, 2, 2, 3 and 3. So that means that at position number 2, there are 3 chips that are the chip number 1, 2 and 3. At position number 3, there are 2 chips, that is chip number 4 and chip number 5, right? Everyone must be clear with this much part. Now moving ahead, let me have a look at the problem statement ahead and let us see that what it says further. Firstly, it was very important for us to understand the problem statement. After that, what it says is you have to move all the chips to the same position, right? You have to move all the chips to the same position. Okay, so you have to move them to the same position. All the chips should be moving to the same position in the end. What you have to do, what you can do is, in one step, in one move, we can change the position of the ith chip to what? Let us see. In one move, it further says that in one move, for the ith chip, what you can do is, if let's suppose that its position will be what? Initially its position will be position of I. So if from this position, if what you are doing is, if from position of I, you are going to position of I minus 2 or position of I minus I plus 2, right? If you are moving from that particular ith index, if you are moving 2 positions towards the right or 2 positions towards the left, then for that the cost will be 0, right? So if let's suppose that your chip is somewhere here, let's suppose that your chip is here, right? This is your chip. Then what you can do is, you can either move to this index or this index, right? That is 2 index from the left or 2 index from the right? Is this much part clear to everyone? Just quickly let me know in the chat. I hope that this much part is clear to everyone. Now another thing that has been given in this question is that now another thing that can happen with you is, let's say the position is position of I. So from that, what you can do is, you can change your position to one step left, that is position of I minus 1, or you can do it to position of I plus 1. That is, instead of moving 2 towards the left or 2 towards the right, you can move to this index, right? You can move 1 towards the left or 1 towards the right, but for this your cost will be 1. Is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Up till here, is this much part clear to everyone? Just quickly let me know. If you are you have to find the minimum number of moves to make all the chips standing at the same position. In the end, you want all the chips to be at the same position, and in one move what you can do is either you can if your ith chip is at the position I, then you can change it to position of I minus 1 or I minus 2 or I plus 2. For that the cost will be 0. Or you can do this, that you can pay a cost of 1, and you can change its index to I minus 1 or I plus 1. This much part must be clear to everyone. Now the question stands that what does it actually mean, right? So let's say if I have this simple example, that is 2 2 2 at 3 and 3. For this, let me write down the indexes. So this is index 1 2 3 4 and 5. What does this mean? So does this mean that I can change these like that? No, that doesn't mean. Why? Because what it actually means is that at position 2, I am saying position, right? At position 2, the chip number 1 is there, then chip number 2 is there, then chip number 3 is there, right? That is what one thing that you need to notice. At position number 3, which are the chips there? Chip number 4 and chip number 5, right? So that means that let's draw a simpler array, smaller array. So what it means actually is that at position number 2 there are 3 chips, and at position number at position number 3 there are 2 chips. Is this much part clear to everyone? At position 2, at the position 2 there are 3 chips, right? At position 2 there is chip 1, chip 2, chip 3. At position 2, at position number 3, at position 3 there are 2 chips, chip 4 and chip 5. Is this much part clear to everyone? I think that it must be clear to everyone, right? So now you tell me what should be the minimum number of moves to bring all the chips at the same index. There are 3 chips at the position number 2, and there are 2 chips at position number 3. So tell me the minimum number of moves for this. Can someone tell me? You can try to guess it, or you can try to give me any answer. What is the minimum number of moves that I can do? If I can say that I can give a cost of 0 and I can change it to position I minus 1, position I minus 2 or position I plus 2, or I can pay a cost of 1 at each move, and I can make my position to position of I minus 1. And okay, you are saying that 2. Why does that happen? That happens because you are saying that I can since both of them are one is even and one is odd, so that is why I cannot apply this operation, that is position of I minus 2 and position of I plus 3, I plus 2, right? I cannot apply this because in that case they will never come at the same position. So what I need to do is I either need to bring the elements, the chips, that is I can either bring the chip 1, chip 2, chip 3 from this even index to this odd, from this even position to this odd position, or I can say that I need to bring the chip at the odd index from this position to this position, right? For that, for each chip I'll be taking 1 cost. So that is why what is the minimum number of chips at a particular index, I need to check that. So we can easily see that the chip is what? The chip is nothing but the chip is 2 at the odd index. The number of chips are 2. So for moving that, my cost will be 2. For moving the chips, 3 chips at the even index, the cost will be 3. So I will find the minimum cost for odd index, for index 2 and index 3, right? So for this, the cost will come out to be 2. Everyone is clear with this much part. I hope that everyone is clear with this much part. Now now you will say that okay, fine, we can do that. But let's say that you have a number of odd indexes. There you had only an index, one odd index and one even index. Now let me take this example: 1, 2, 3, 4, 5. Now let me do the indexing part. Let's say I index it as let me take other numbers so that we can change them in a better way. So let's say I have 6, 7, 8, 9 and 10, right? This is what I have. And let's say that I index is at 1, 2, 3, 4, 5. So what it says is it says that at position number 6, how many chips do I have? I have one chip. I have one chip at position number 6. How many chips I have at position number 7? Only one chip is there. That is chip number 2, right? I have only one chip at 7 as well. After that, how many chips do I have at index number 8? Index number 8, at index number 8, I have only one chip, that is chip number 3. At position number 9, I have only one chip, that is chip number 4. At position number 10, I have only one chip, and that is chip number 5. Is this much part clear to everyone? Just quickly let me know in the chat. Now tell me the minimum number of moves. What is the minimum number of moves required? Just quickly tell me in the chat. What is the minimum number of moves required for this one? Anyone can tell me in the chat what should we do for this case? What is the minimum number of moves that we require for this case? Either you can change your positions to either for a particular position I, you can pay a cost of 0 and you can change to I plus 2 or I minus 2 and you can pay a cost of 0 for that. Or what you can do is you can change your position of I to 1 towards I plus 1 or I minus 1, and in this way you can pay a cost of 1, right? What should you do? What will be the minimum cost for this one? Can someone in the chat tell me? Can I say that this is an I? Can I say that I can move this to this index without any cost? Because from position I, that is 6, I can move to 8 by spending just one coin, right? By spending no coin, because I can move I plus 2. I can move I plus 2 towards the right. That is, I can move from I, where if my I is 6, then I plus 2 will be 8. I can move to it without paying any cost. So that means that this will be gone from here. So this will be 0. Now at 8 I have 2. At 8 I have 2 chips, right? At 8 I am having 2 chips. Now let us have a look at this. If I have this 10, can I say that from this 10 I can move to this index 8? Can I say this? Yes, I can say this. So that means that this chip from this index 10, it can move to index this 8. So now from 2, the number of chips increased to 3, right? Everyone will agree to me on this part, right? I hope that everyone agrees to me on this part. Now this much part is done. Now let me do the index part. So this is index number 7, this is index number 9. Can I say that if my I is equal to 7, can I say that I can move to I plus 2, which is 9, without paying any cost? Because I can do this without paying any cost. Can I say this, that this will now become 0 and this becomes 2? Can I say this? Now tell me, what is the minimum cost now? Can you tell me? Now tell me. I want the answer from all of you. Now tell me, what will be the minimum cost now? Can someone in the chat tell me? I want someone in the chat to tell me the answer for this. Can someone in the chat tell me the answer for this part? For this part, what will be my answer? Now I have a chip at index number 8, right? Why 2? Because now what happens? Now the requirements are changed. At position number 8 and 9. At position number 8 you have 3 chips. At position number 9 you have 2 chips. So what you can do is you need to now move from I to I plus 1 or I to I minus 1, right? So if you see this, if you will move from this even index to this odd index, then you will be paying a cost of 3. If you move from the index number 9 to index number 8, so you'll be paying a cost of 2, right? So that is why the minimum will be what? 2, right? So the number of moves for this case is 2. Now how will you determine the answer? Can someone in the chat tell me? Let's say I give you a test case. Let's say I give you let's say I give you 4, 5 and 6 and the index is 1, 2 and 3. What will be the minimum answer for this case? What will the minimum number of moves for this case? Can someone in the chat quickly tell me? What is going to be the minimum number of moves for this case? Anyone would like to tell us? Anyone can voluntarily tell us. What will the minimum moves for this case? can I say that at position number 4, let's draw it on the top right corner. Can I say that at position number 4, at position number 5, at position number 6, I'm having one chip each. I'm having one chip each, right? One, and one. At position 4, I have one chip. At position 5, I have one chip. At position 6, I also have one chip. Now what I can do is I can see that from this 4, I can move to this 6, right? So let's do that. So this chip, now the number of chips here are 0. Let's change this. Okay, so this will be 0, this will be 2, right? Now tell me what is the minimum number of moves. Now I can see that the minimum number of moves now will be nothing but 1, right? How do I determine that? How do I determine that? In the chat, can someone tell me? If you see the number of chips at odd position of I is what? It's 2, and the number of chips at the all the even position of I are 1, right? At the odd, not sorry at the odd you have one chip, at the odd you only have one chip, and at the even you have two chips, right? You have two chips. So can I say that I can move all the chips, all the even index chips to one particular index? I can say that I can move all the even number chips to one particular index. Can I say this? I can move all the even number chips at one particular even index without paying any cost. Can I say this, that I can move all the even position chips at the one particular even index without paying any cost? And I can do that because I can skip 2, and even numbers are also coming at a difference of 2, right? Can I say that I can also do the same for the odd indexes? That is, I can move all the odd indexed, all the odd position of I chips to one particular odd position of I, and I will not pay any cost for that. And after that, can I say that there will be an index I, and there will be an index, let me just draw it clearly. So can I say that after this, what will happen? There will be an index I, and there will be an index I plus 1, such that, let's say this is even, so this will be odd. I'll be having the count 1 here and the count 2 here. That is, count 1 represents the number of chips at the even index, the ith even index, and the number of chips that are present at the odd index, right? After that, can I say that the answer will be minimum of C1 comma C2? That is the total number of chips that are at position of I. If the position of I mod 2 is equal to 0, then I'll do a C1 plus, let's say. And if the position of I mod 2, if it's equal to 1, then I'll do a C2 plus, right? Everyone is clear with this much part. I'll count the positions. If the particular position is even, then I'll make them all together without paying any cost. That will be C1. The cost for that will be C1, and I'll make all the odd positions, all the chips at the odd positions at one place without paying any cost, and the total number of such chips will be cost 2. And I can say that I'll be having C1 number of chips here, C2 number of chips here. Let's say this is even and this is odd, anything or even an odd and even. So I can say that the answer will be minimum of C1 comma C2, because now I need to make a move. I need to do from I to I plus 1 or I to I minus 1. If this is I, then it will be I minus 1. So I need to make adjacent, since I want all of them to be clubbed together. So I can either do this or I can either do this. I'll do the one which is minimum for me, which is minimum, right? Which is minimum. The minimum number of chips can either be at a particular even, at the even index or at the odd index. Is this much part clear to everyone? I think that this much part is clear to everyone, right? So let me write down now in the end. What I'm saying is, I said that, let's say we have a array that is 1 2 3, not this, sorry. Let's say I had an array. Let's say it was 21 22 23 24 and 25, right? If it was this, so what I'm saying is this and this. Notice that all are position of I, right? All are position of I. This is index 1, index 2, index 3, index 4, index 5. This is the chip number, right? This is the chip number. Now I'm saying that you run a loop. I start from 0 and I is less than n. that is I is less than pos dot size and I plus plus, and if my position of I mod 2 is equal to 0, then I can count the even plus plus, that is I'll make all the even index, all the even ones, that is this even will be what, 22 chip number, chip with the position 22 and 24. This is the chip number 2 and chip number 4 will be at even positions, so I can either make all of them at 22 or 24. Similarly, can I say that I can club all the odd indexed, right? Else, if that is not the case, if the position is odd, can I say that I can, if I am clubbing all of them at this even index, can I say that I can club all the others, all the odd, like this and this I can pick, and I can, this 25 and this index number 21, position number 21, I can make them to 23, and in this way the total number of chips I can have odd number of chips together without any cost. And since they will be adjacent, so the final cost will be minimum of even count comma odd count. Is this much part clear to everyone? Is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Just quickly let me know in the chat. I want a quick answer. I hope it is. Okay, perfect. So for this what I'm saying is, for this question, the time complexity is going to be order of n, because I am iterating through the position array once, and the space complexity for this code will be order of 1, because I am not using any extra space. That is why. Can I say this? I can, right? Let's move to the code part for this problem. What does the code look like? It is very simple. It is very simple, believe me when I say this. I'll be given, let me bring it a little bit down, right? What I'll be given is, I'll be given this cost function, and what I have to do is, I'll be given the position. I can have a counter of odd and a counter of even. Notice that I mod 2 is, don't have to check I mod 2, because I is for the chip. I need to check for the positions. I told you in the sample dry run, you can try to watch the back part, or the part where I told you the exact problem statement. So if the position of I mod 2 is, if all the I will club together all the even positions by doing I plus 2 or I plus I minus 2, I'll club all the even positions together, that will be even plus plus. I'll count all the chips that are present at the even index, at the even positions, and I'll count all the chips that are present in the odd positions, and both of them I'll make them adjacent without paying any cost. After that, my final cost will be the minimum of even positions, minimum number of chips at the even position, the odd position, right? Everyone agrees to me on this. I think everyone does. Is everyone clear with this much part? Everyone is clear with this much part? Just quickly let me know in the chat. Let me show you by submitting this problem as well. So I am clicking this submit button. Let us see whether it works or not. Okay, so it is still judging. You can see that this problem got accepted, right? You can see that this problem here, it got accepted, right? One mistake that you could have done is, that you could have done the same mistake that I did in the morning. Let's see whether it opens or not. Yeah, right. So if you do I mod 2, an I mod 2, then you will be at trouble, because I is for the chip. I is what? Chip I is chip 1, chip 2, chip 3. Position of I is what matters. Position of I mod 2, position of I mod 2 equal 1 or 0. You don't have to do it for the index. Notice that this was important for the problem. People will say that this problem was tricky or the problem statement was not clear, but I'll say that is not the case. The problem is absolutely clear. All you need to do is you need to read the problem statement in the correct manner. Okay, so this was it from my side for today's lecture, for this live stream. Also, one more thing, we'll be doing this LeetCode daily challenge every day. We'll be doing this LeetCode daily challenge every day. Okay. And we'll be bringing mastering codeforces series again. Also, you can subscribe the channel for codeforces editorials as well as atcoder editorials and other contests, major contests like Kickstart or anything like that. Apart from this, if you haven't subscribed the channel, if you are coming for the first time, so you can consider subscribing the channel, and you can hit the like button if you liked my explanation. I'll be providing you the code in the description part. Apart from this, make sure to share it with your friends and keep coding. Till then, I'll see you in the next one, right? Thanks.